The passion, the energy, the power, the spirit of hardcore.
So, hello and welcome to the final panel of the day and of this year's Hackers Congress. Let's talk about the future of freedom tech, where things are headed. So maybe give us a quick insight of your bubble. What are the things that makes you excited about in your field of expertise?
Sure. Yeah, I work mostly on snarks, somewhat for privacy stuff, but just proving in zero knowledge things. Recently published the shielded CSV paper, which is interesting maybe for like a meta protocol for privacy stuff on Bitcoin. Yeah. Work at Alpen Labs.
So what's the TLDR on shielded CSV? Why is it cool?
It's interesting because it moves there's like a confluent kind of evolution of a few different things. But one way to think about it is it moves the proofs for something like Monero or Zcash off chain. And you can recursively validate them on the client side, which is useful for a meta protocol because you only have to put the nullifier on chain. So yeah.
Yeah, I think that would allow for a lot of privacy improvements to happen on Bitcoin actually directly.
Yeah, I mean the bridge between sort of Bitcoin proper and Bitcoin, shielded CSV is still very much a work in progress. But yeah, I mean the goal of the project was to add private transactions to Bitcoin.
Yeah, so I'm at Sirion. Hi, I'm working on Fediment, and I would describe it as like the best we can do until we actually have on-chain privacy or privacy on like a trustless extension of Bitcoin, which is like you can think of it as a group of people that come together to run a multisig and then give people access, like kind of IOU tokens, which they can access the Bitcoin that are held in the multisig, and they can trade them. It's all very private. They can make lightning payments. Like I've been paying all my coffee here at Paralelní Polis with Fedi for the last year. And yeah, so it gives us a lot of scalability, a lot of privacy, with the caveat that you kind of have to find a group of people that you trust to actually hold your Bitcoin. But if you can do that, if you have a community, then that's a great solution, I think.
I think that aspect of having custody over some assets is quite inherent in how humans operate, and so it probably will still be here in the future. It's quite a cheap technology, it's a cost-saving technology, so it still makes a lot of sense, and it's just mind-blowing that nowadays it's possible to have a fully federated money warehouse, like where the money isn't in one location at any one point in time, but it's split up in this metaverse of cryptography, where different computers work together to actually take custody of that money. It's just an absolutely mind-blowing concept. And I mean, the idea was actually introduced here originally in 2019 with Scrid. And Fediment is actually making it a reality finally.
Yeah, I got my inspiration from Smuggler and Frank Braun. So thanks a lot for bringing this technology into the 21st century.
So how about the network layer of things? How are we doing there?
Yeah, so I'm Max. I work for NIM, and yeah, NIM is a mixnet. So basically adding like network layer privacy, both in terms of your actual traffic payload, but also metadata protection. So really the dream is to essentially like be the network that undergirds everything that these guys are talking about, and then we can have truly censorship resistant and full privacy on the network layer metadata with our federated Bitcoin, with our off-chain stuff, and then we have the full privacy stack, hopefully, so we can start really building these kind of like autonomous parallel whatever we want, basically.
Yeah, and I think it's really important to stress here that without network layer privacy, we cannot have any privacy on the layers above.
No.
Like the foundation has to be strong.
Yeah.
So all our work, like be it Bitcoin privacy, like messaging privacy, anything relies on strong foundations. And I think what you're working on with NIM, the next generation of privacy networks, it's really, really important, because I think most people are aware of that Tor has its weaknesses, and it's becoming easier and easier for like nation state level attackers to just de-anonymize people.
Yeah, because de-anonymization now fundamentally is like driven by machine learning, right? So you have, and the apparatus of who can actually capture all of this network traffic is like, has really been shunted away from the nation state. I think when people were like originally talking about some of the possible attacks with Tor, like timing attacks, traffic analysis attacks, stuff where you basically just need to capture like huge amounts of data and then crunch it through various machine learning algorithms. That now is a lot more trivial. And I think also something that's like not necessarily just a nation state thing. That's just more, do you have the compute and storage thing? And we do have like certain global duopolies, oligopolies of people who have vast amounts of like private compute that they can kind of shunt towards this.
And you don't necessarily need to compute. You just need the money to rent the compute.
You just need the money. Yeah, exactly. You need the money to rent the compute, or you just need the money to buy already kind of captured traffic. Or, you know, obviously, like we're also looking at stuff like forward secrecy, so that in maybe 5-10 years, I don't know, if quantum computing kind of lives up to its promises, then someone can't basically go back through everyone's back history and at least see, you know, break TLS and see the history of everything that's happened that they've captured previously. So yeah.
So if you look back 5 years and compare to today, how did NIM do? What improved?
Well, it exists now, so that's I think that's a big initial improvement. I mean, now basically we're kind of at the stage where we have a functioning mixnet. It is, and now we're working on a mixture of optimizations kind of across the stack. We're also working on like a credentialing scheme, which is maybe later in the conversation. So a mixture of like crypto speedups. I do DevRel. Been doing a lot of deving recently, like working on an initial kind of integration with Zcash, but hoping to kind of really genericize that. So also really looking at previous stuff, looking at stuff like how the RT client works from a dev experience point of view, to kind of build abstractions on the mixnet, right? To make it a lot more like reasonable to use, give something more that's like a streaming socket to developers, so we can also get people in, because a lot of the work that also goes into stuff like this is really social, because you need a base level anonymity set. Otherwise you could have like the most perfect mixnet in the world, but it still would be kind of, it wouldn't necessarily live up to like all of the kind of privacy properties that you want it to. So yeah, it's also a social aspect of onboarding and just getting people using this thing.
How about latency and such?
So at the moment, I mean, a mixnet naturally is better for like asynchronous operations where you can have a little bit of extra latency. So your messaging, perfect for crypto apps where you're already maybe waiting like a minute or tens of seconds for a confirmation. Email, I mean, email was the kind of the classic original use case, right, that John was talking about. It was anonymous remailers. You know, and we are building on like a history of people, all of the anonymous remailer projects, Mixminion, Mixmaster, like all of these other things. At the moment, yeah. So at the moment you couldn't necessarily do web streaming. We're working on like a kind of a side thing, a 2-hop kind of WireGuard in a WireGuard tunnel, right? So people can also do the kind of like streaming stuff as well. But yeah, that's kind of, I would say, slightly separate from the mixnet, but might also kind of open the door for people to kind of get into the mixnet. So as soon as you can do something like application-specific tunneling, then you can kind of have this more VPN-ish thing kind of running in the background, but then your crypto apps, your, you know, whatever, Thunderbird, Proton, email, everything, your Bitcoin wallets, then like tunneled through the mixnet as well. Yeah, but we're working on a lot of speed ups too.
But I think the messaging support is actually one of the most important things, because like we might all be enjoying watching silly cat videos online, but the really important stuff is being able to coordinate in an anonymous manner,
exactly,
in an uncensorable manner. And yeah, I think that's where mixnets really shine. And like we are living in a world where like we just had a renewed attempt at pushing through chat control. And like eventually I think they will succeed. And we need alternatives that like are open source that cannot as easily be surveilled. So they don't come to you to say, oh, you're using this unauthorized chat app. Yeah. And so you're laying the foundations here.
Yeah, I think especially for people running nodes for completely different projects that are running all of their networking traffic through it, it will also hopefully engender people, especially in like the peer-to-peer context or whatever, people who you're looking at kind of the renewed crackdown against like Tor nodes at the moment. People are obviously kind of spooked to run bits of privacy infrastructure, but if people can run their chat app and stuff, or their chat node, their seed node for their you know, peer-to-peer encrypted chat, but they can like send all of their messaging through the network, then that also gives hopefully it's going to not only protect existing stuff, but buoy people up and kind of enable people to feel a lot safer when they're actually running other bits of infrastructure for other projects. So really, again, it's like we're trying to make it just this like very, very foundational thing that people can then just build on top of.
There's great advancements on message encryption as well. Of course, we all know the Signal protocol, which recently got extended or advanced in the Message Layer Security Protocol, MLS, an open standard and a open implementation of this key ratchet encryption scheme for small direct messages as well as large groups into the hundreds of thousands of people. So this can be deployed together with an anonymity network like Tor to transfer, for example, shielded client-side validated proofs. So these technologies are slowly but surely coming all together. Yeah. Liam, how would you compare RGB, for example, with your current protocol? What is the improvement?
I'm probably not the best person to do that. I know Jonas talked with the RGB people more about what it sort of specifically is to compare. But to say what the shielded CSV thing is, it's there's this kind of old idea that predates, I think, all of the projects from maybe Peter Todd or I don't know, but you can separate the validation of transactions from double spend protection of transactions, and in doing that, right, you can put only sort of commitments to transactions on chain, and that will give you double spend protection. But in order to get the ability to validate transactions, you have to be able to sort of recursively inspect the history. And so the kind of original conception of this, or the pre-snark version of this, would require sending large amounts of data or using some sort of more complicated protocol to avoid that. But with snarks and the development in zero-knowledge proofs that's occurred over the last 10 years, I think the most straightforward way to do it, and the way that we propose in shielded CSV, is to recursively validate transactions using snarks. So rather than sort of going backwards in history and verifying everything directly, you just verify proofs of the input transactions to a given transaction inside of the proof of the next transaction. So yeah, to compare with RGB specifically, I'm not sure.
Yeah, I think, for example, RGB by default doesn't use zero-knowledge proofs at all. So
I think that's right, but I'm also not sure. I think also one sort of difference between other client-side validated protocols and ZK coins and shielded CSV is the usage of the Bitcoin UTXO-stat versus like a sort of client-side maintained alternative object. So we don't use that. I believe RGB does.
Yeah, so I think with RGB, whenever you make a transaction off chain and you send to the receiver the proofs necessary for him to be satisfied that this is a valid payment, these proofs are unencrypted, so to say, and reveal almost like a little private blockchain of all the transactions that this token has done in the past. So even though a public global adversary might not know this information, the people involved in the transactions can still see a transaction graph. And now with the incredible advancements of zero knowledge in the last couple of years, we can compress this blockchain, so to say, in a tiny proof that doesn't even increase in size with the number of transactions.
Yeah, exactly. That's right.
So one thing that I kind of wanted to talk about on this panel is, like, we all know what we're working on, and that's currently what we think is like the most important thing, I guess. But like, I would be very interested in where everyone thinks things are going. Like Paul gave a great talk where he introduced the concept of hacking ahead, like seeing where things will be in like 5 years, in 10 years, and working towards solutions that will help us at that time. So yeah, I'd like to talk about what.
Sure. I mean, one thing that probably should be on everybody's mind is quantum computers and their impact on cryptography. So quantum computers allow people to solve the elliptic curve discrete log problem, which breaks sort of elliptic curve-based proof systems and pairing-based proof systems, which are a subset of that. There are a number of different like proposed post-quantum schemes, and they're currently undergoing review from academics and such. In terms of zero knowledge proofs, right? There's this like Starks. It's kind of a separate category of zero knowledge proofs are post-quantum resistant, or at least they can be in principle, and use only hash functions. So that's cool. For things like signatures, there's also lattice-based cryptography and isogeny-based cryptography, which was very recently broken, but repaired. So, do with that information what you will. But yeah, I mean, there's lots of people working on it. But I think in terms of the security of decentralized payment networks or communication in general, we should be paying close attention to post-quantum schemes. And I guess shielded CSV, right? Like, because the proofs are kept off chain, is amenable to, say, Starks, which the proofs are much larger, which ordinarily would make them not sort of suitable for on-chain proof cryptocurrencies. But when you keep the proofs off-chain, it sort of works well.
Yeah, I fully agree there. Like, I think recently many people have become a little bit more optimistic when it comes to when will we actually have quantum computers that are usable. And that's unfortunately a very pessimistic outcome or outlook for cryptography as we know it. So I think at least we should have a plan as Bitcoiners. And yeah, so everyone working on these things, that's
Fix it.
Yeah, fix it. I think another thing that we should fix before it's too late is Bitcoin privacy without specific tooling, or like getting Bitcoin privacy as the standard, the default. Because I think what we have seen, and you can probably confirm it with Wasabi, like when people use specific tools to improve their privacy, and these tools leave a footprint, then these people will be censored against. And that's a huge problem. So I think another problem to solve over the next decade or so is, how can we sneak privacy by default into Bitcoin again? Like, it wasn't there in the beginning because it's complicated and you need to start with something. But I think the goal should be that like privacy isn't something that us weird people do because we feel like we need privacy, but something that everybody should do. And so you cannot censor them.
And I think the caveat here is that Bitcoin is not a single protocol. This is a stack, a suite of numerous protocols, and privacy should be considered for each of their designs. So it's not just that we have to solve the problem once; we have to solve it in a systemic way. And yeah, that's tough. But thankfully, we have a decent number of cypherpunks working on good technologies that can then be leveraged by other devs.
Because I mean, it is also like it's a to and fro, right? You never solve the problem. You solve the problem for the moment, or you get ahead, and then there's other advancements. It's always this toing and froing of everything. But I think there is also, we are kind of getting to the point, just from the technologies that people here are talking about, but then also stuff that like other people have been talking about. You have like anonymous DAOs now, you have anonymous swapping, you have all of this other stuff, that these pieces that previously were quite disparate, you know, obviously there's been like a lot of talk in like, especially the rest of the blockchain space about interoperability, modularity, all of this kind of stuff, which is also, all the pieces are kind of being able to like slot together a lot more at the moment. And I feel like there is also the massive cultural resurgence of like cypherpunk in general across maybe communities that kind of like fell away from that a little bit recently too. So people are also being pulled back into this. And the fact that we also have defined problems, but we also have like very defined things where like, I mean, you onboarded me to Fedi yesterday and it took 2 minutes and it was just a breeze. So, and yeah, as soon as we can start combining that with like, oh, and you can run all of this over a mixnet, you can have like, just kind of, you're kind of removing all of the trails from other proof systems that you've had, like all of this stuff really starts like stacking up as well. So I think there is also like a massive cause for cautious positivity, but like positivity nonetheless, right?
It's just a lot of work.
Yeah, it's just a hell of a lot of work, but it's fun, so yeah.
No, but it is certainly possible to provide useful services while having privacy as a default. In fact, a lot of services are only possible if privacy is set as the default. So yeah, we have more and more tools that keeps continuing advancing. Adversaries are obviously also advancing at a quite staggering rate, so that is not to be underestimated. But yeah, we have smart minds too working on this.
Yeah, and you mentioned me onboarding you to Fedi, and at no point did it say it's a privacy app, but you get a privacy for free. And I see something very similar in shielded CSV. Like it's a scaling solution, most fundamentally to Bitcoin, but it also, like through the backdoor, will bring privacy.
Yeah, I think snarks have so often, right? Like you have to like add privacy intentionally, and it costs something. But with I guess blockchain stuff generally and snarks, right? Like you kind of get both of them for free, right? Like by not putting the data on chain at all, you get some kind of privacy, and you also get scalability. And I think that I'd like to see people exploit that more, but definitely the shielded CSV thing, kind of the privacy falls out almost for free from the protocol.
And I mean, just to let that sink in, but like with shielded CSV, you put 64 bytes on a blockchain, and you can settle hundreds of thousands or millions of transactions, right? In a way that nobody even knows how many transactions exactly happened. And for sure not the details of these transactions, like who sent whom or how much or what asset. So it's quite staggering. We've gotten good at compressing economic activity into very few bytes.
Snarks are very cool.
So I'm sure there's a bunch of questions in the audience as well. Feel free to raise your hand and someone will run a mic. Any other topics you guys are interested in to cover before?
I mean, you were mentioning credential schemes, and I think everyone on this panel has been in some contact with cryptographic credentialing schemes. And
We're all blind signature nerds here.
Yeah. Kind of. We could make this the blind signature panel, but I don't know. Like if anyone else has questions about the original topic of Freedom Technologies, then that would also work.
Do we have a mic runner? There is no technician here.
I'll be the mic.
Anarchy.
Yeah, so there seems to be a real disconnect between, I would say, some of the way people are pushing Bitcoin. Like Michael Saylor clearly said that cypherpunks should be kind of banned from Bitcoin so they can give it to the banks and pump the price and get everyone rich. how do we implement these freedom technologies? Well, it seems like the two sides are are going between two different paths. How do we get snarks and zero knowledge proofs at second layers at scale when, certain, big banks might be pressuring the mining pools to censor certain transactions?
I mean, we just do it.
Yeah, but like if we just do it, but then there could be a world where the monetary kind of game behind Bitcoin and the centralization behind it could, pressure people to kind of get everyone out, and we have to move to new systems. How do we kind of ensure that we can kind of ensure that Bitcoin has the cypherpunk roots and cypherpunk ability to transact at scale if there's this like globalization effort behind it?
I think the scalability and privacy aspects of snarks and ZK snarks allow you to kind of backdoor in privacy, or at least the potential for more private transaction models via scalability solutions, because you kind of get both in a way that's sort of impossible to separate, which is perfect for us.
And I think fundamentally we need to make sure that Bitcoin stays a medium of exchange. Like, I think if it was only seen as digital gold and is only used as like an ETF backing asset, basically, then I don't think we could achieve that. But as long as Bitcoin is actually being used, then like these technologies are so useful in of themselves, like even without considering the privacy aspect, that I think we'll be able to sneak them in.
Yeah, I think the only thing I can add to like those two things is that, I mean, none of this is monolithic, right? This whole like culture, everyone here is also not monolithic, and just kind of going back to what Max said, like we just have to fucking do it. And if we do it first, then we've done it first.
I've got a question here. On that question, I'll pass the low ball to you, Max. I think you should actually touch on those anonymous credentials, because I think for the folks here, it's one make a big difference between voluntary run services, between honeypot Ponzi scheme wannabe privacy, and between actually incentivized real privacy with users out there, and also the possible generic usage in the future.
Yeah. Okay, cool. So I'll go over the kind of credentialing scheme that I kind of brought up a little bit before. So it's a combination of the Coconut credentialing scheme and the offline eCash scheme. And the core reasoning behind it is that it's buoying up the use of something like a mixnet, where in terms of de-anonymization, your attacks are kind of like, they're probabilistic, right? You essentially kind of capture all this traffic, crunch it with machine learning and all of these kind of other techniques, and you kind of can say, well, we have a kind of, within X bounds of certainty that maybe actor A was talking to actor B at this point. So need to get this kind of entropy floor, which you can only get by having a certain size of an anonymity set. And the credentialing scheme, what it basically allows you to do is it's a blind, I'm definitely going to miss off one of the attributes. Basically, it's like a blind signed re-randomizable scheme which relies on ZK proofs. So you have a distributed quorum of people who are kind of essentially running like our partial credential generation. And the way that you can get a credential is you can actually make a payment in like a pseudonymous cryptocurrency. You could even kind of like do something where you hook up a payment infrastructure with something like fiat if you even wanted to, right? But you can then basically construct like a very small proof that basically says that, it's an attestation that you've made this kind of payment. And then all the other public stuff is completely de-linked from everything that then follows on from here, which is it's a threshold crypto scheme. So you kind of ask X number of these people, they'll give you a partial credential. You can then kind of create a full credential out of it. And then every time you basically want to use it, in this case, like initially the first version of this is we're using it to kind of like gate access to the mixnet, because it's incentivized. We need to kind of, the thesis is that if you can also financially incentivize operators as well as kind of ideologically, then maybe you can have more robust services than just free ones. It's a thesis. We're going to see if it works out. But we will make it generic in the future. So then you basically, every time I kind of want to present a credential that says, hey, I've kind of bought bandwidth to go through the mixnet, then you re-randomize it. The actual binary data that I give to you, for instance, is completely unlinkable to any other credential that you have ever seen or will ever see. But you can always verify that it's a valid credential, like a valid sub-credential, basically, that you've generated. So what you can do is you can have more public payment methods that you can attest to, but you can like completely disintermediate then from any usage of the network that you're using to gate. And as soon as we can make this generic, then you could imagine doing that for like any service, basically, which I think is also, if we're kind of talking about, things that partially have to scale, but partially are also just these kind of like parallel structures of organization, of services, of whatever, then having the ability to kind of anonymously gate those either with payment or just like anonymous gating, you remove so much in terms of the risk for you as a user to use this, whatever, the next version of like Tutor Autistic Inventati or something, if like the servers are, taken. But you also remove it from the people running the service because then you're not holding any data. Someone could come and try and like lean on you and go, hey, what's up? Give us all of your user data, but like there's nothing there. So again, you're kind of like, you're removing possible vectors of attack from both the people who want to use it, but also the people who want to like run this kind of next generation of parallel kind of society infrastructure that we've all been talking about for quite a long time. And I think that's like on the cusp.
Yeah, there's the saying, if you're not paying for it, then you're the product.
Yeah, exactly.
Stop being the product.
Yeah, and no, that's really a key aspect that as a service provider, if there is a way to offer the service in such that the user does not offer data to you, then that's excellent because there's no honeypot to protect.
Yeah, there's nothing you need. You can cryptographically verify that everything's chill, and it is.
It's hopefully an assurance that to be left alone, because there's nothing to get. And that is always useful.
Definitely. I mean, it's kind of what, it's what Jaramil was bringing up yesterday as well when he had, he was saying people, the police kind of came to his door because he was running the second fastest Tor node in the EU, and he was like, well, we have nothing, and kind of explaining the service, but you're actually removing the possibility maybe that they're even going to try and pull that on you. And it's just, yeah, you can just run an email service because you should just be able to run a fucking email service.
Yeah, it's great to be in a position that if someone wants to see your logs, you can just give it to them.
Yeah. That's also like a core principle of Fediment, actually. Like I recently built something called Fediment Observer, which takes like all the public data from Fediments and just shows statistics. And like my view is, if there's any data that's viewable by like the guardians that actually run the federation, and that should be public, and people should see what guardians can see, because then we still have work to do to protect more of their privacy. Mm-hmm. And you were mentioning the coconut credentialing scheme, and that's actually something we have looked into for like the next generation of Fediment eCash. And we already have like a protocol that uses coconut credentials and something very, very much like the Wasabi 2.0 like blinded amount committed eCash. And I'm really excited. Like it will probably take another year or so, but for that new eCash module to roll out.
Yeah, if we're each sharing our favorite credential scheme, then let me talk a bit about Wabi Sabi, because the problem was basically anonymous API access right management. And you have a service, and for all intents and purposes, on one side of the service you get paid, and on the other second API call you want to provide the service. The second API call should be reachable by anyone with a Tor identity or NIM identity. However, you want to limit access to the second API to only those people who successfully paid in the first API call. And eCash is the perfect technology to cut the link between these two API calls while still remaining perfect security. And the downside of our initial use of Chaumian blind signatures is that the anonymity set of these transactions is strictly limited to the amount of the token. So in Wasabi 1.0 use case, this was 0.1 Bitcoin. And so the mint or the coordinator generated a blind signature with a single private key worth the 0.1. And so if someone wanted to register 0.15 Bitcoin, the coordinator doesn't have a private key of this value to actually represent the token. And that was a large usability concern, which also resulted in higher block space consumption than was nice. So ultimately, the innovation was an eCash scheme with anonymous amounts. So for this, we switched to keyed verified anonymous credentials, which was first introduced in the Signal paper from 2019. And adding as an attribute of these credentials a Pedersen commitment, shielding the amount of the token. So whenever you make this eCash transaction, you're always spending 2 tokens and creating 2 new tokens. And you're basically proving in zero knowledge that the sum of the inputs equals the sum of the outputs. So for example, 2 plus 3 equals 5 plus 0. But the mint does not know any of these 4 values.
Yeah, we all have our favorite credential schemes, but I'm wondering, the more progress we make in zero-knowledge proofs, maybe one day, like all these credentialing schemes, they're kind of custom made, but maybe one day we'll just have general purpose zero-knowledge schemes that are so powerful that, well, we just make zero-knowledge proofs that the mint owes me money.
Yeah, I think probably, right? I don't know. I think you can do anonymous credentials with snarks as a general primitive, and the statements you're proving are always simple enough that it's probably not, especially if it's being shared peer-to-peer and not like on-chain or something. The proof size is probably not a significant consideration. Yeah.
I mean, in the eCash scheme, I'm thinking that for an eCash credential, you could simply add a zero-knowledge verifier as the spending condition, and
that would be very exciting, because then suddenly we could have eCash that is natively multisig, or like that has time lock in it, like so many.
Or any Rust code you want.
Yeah.
Like to attach a spending condition to an eCash token or something, like with a script.
Yeah, exactly. And if your like blind signature in quotation marks is already like a zero knowledge proof, basically, then it's pretty easy to also add more spend conditions, right?
Yeah, one of the downsides of current approaches of adding spending conditions to eCash is that the mint is the one verifying the spending condition in clear text. So the mint sees that this eCash is locked to the specific pub key, and if that is your Nostr profile pub key, then it knows basically who you are or who received money. And with zero knowledge systems, this information could be hidden from even the mint.
Yeah, I think a lot of this stuff is in the process of, well, it's already gone from theoretical to practical, and then it's just a matter of tooling to like make it easily usable by stuff. But yeah, this is all very much feasible, I think.
I think one of the very interesting effects of our time is that there's now a financial incentive to actually build these very, very complicated systems and make them usable. Because like zero knowledge research, it has been around for a long time, right? But like now we're really seeing it to become practical. Like you probably have the better perspective on that, but that's my impression I get as an outsider.
Yeah. I mean, it's crazy. Companies like RISC-0 or Succinct or whatever, they can prove Rust code at like almost a megahertz, so 1,000 times slower than actually running the program, which is pretty impressive. I mean, given that even 20 years ago, I think we were like quadratic complexity for provers or something like that. So yeah, I think I forget what the number is, but something like 100x per year prover improvement over the last like 5 or 10-ish years. So hopefully that continues. I mean, we're pretty close to real-time proving. I mean, one nice thing about snarks and zero knowledge proofs is that they kind of scale horizontally very well, because you have the thing you're trying to prove, and you can, if you have the whole trace ahead of time, you can prove parts of it in parallel and then combine them in a tree. And so that means that even, I don't know, some of the metrics, even the companies that are doing proving have changed. They're like measuring it in dollar terms as opposed to time, because you can scale out horizontally, which is sort of interesting. But yeah, like real-time proving is very probably close.
By the way, we'll keep talking about credentials and ZK proofs until you interrupt us with better questions. So if you have any more. Until then, how could NIM benefit from some zero-knowledge crypto?
I mean, I will admit that like my most of my speciality is far more on the networking side rather than necessarily on the ZK side. I mean, there's kind of always a bunch of well, let's say crypto speedups anyway, right? Anywhere in the system. So like you know, we're using Sphinx. Sphinx has been around for quite a while. Lightning uses Sphinx. Everyone kind of knows and trusts Sphinx. We're looking at kind of, let's say, shifting to like a slightly slimmer system as well.
Sphinx. What's Sphinx for the audience?
Oh, sorry. So Sphinx, Sphinx for the audience is it's a packet format that was authored quite a long time ago, and it's basically a it's
onion routing.
Yeah, it is onion routing, really, right? But it's onion routing with like a couple of extra nice benefits. So what you're essentially doing with it is you're as well as having stuff like message padding, where each kind of each Sphinx packet, each layer, right? They're all padded to be exactly the same size, and there's also a bunch of attributes that you basically have where if you're doing, say, if I want to, you know, send traffic to you via you two guys, then you will always have a kind of a temporary session key that's essentially created between me and all of you guys. So that gives you some nice it gives you some nice protections against stuff like replay attacks, where you could like capture some packets and just keep sending them through. But then also, by the time that you have a Sphinx packet that's been passed from him, then you can't tell where in the hop you are because of all of this extra padding stuff and all of this. So it's just like it was already there, and it was very nice to kind of like work with for the mixnet. But we're looking to optimize that with something called Outfox, which is kind of slim down some of maybe the extra stuff that we don't need, and it allows us to kind of more arbitrarily kind of increase payload size and all of this kind of stuff. Yeah, basically.
Yeah, one other aspect, not much related inside cyberspace, but important for the manifestation of cyberspace is meat space. And I think that's something important for the future to consider as well. Because if we don't have a secure environment to run our computers, then all our magic cryptography kind of breaks. So it's going to be an interesting quest to ensure that we have secure dwelling places where we can meet and gather and compute. What do you guys think? Any insights here?
I really like the idea that I think got first like formulated by Frank and Smuggler about the temporary autonomous zones. And I think in your talk, maybe someone mentioned this time, like the Congress, the HCPP is in and of itself some sort of temporary autonomous zone, because in here there's like no state force really applied to us. Like we live by our own rules here, and that's anarchy. And I think that's a viable way, at least for like us working together in meat space, living in meat space. For compute, I don't know. I think it would be great to have like protocols that allow us to like rent out compute, and like where it's verifiable that the operator cannot inspect what is running, and like kind of secure execution environments. But yeah, so far they've all been broken. So I'm not sure if I'm that optimistic about it.
Yeah, I mean, there's other kinds of fancy cryptography that we can use for that specifically, like outsourcing compute to other people, right? Like verifiable, fully homomorphic encryption is, I guess, sort of cutting edge, but I don't know. I mean, I'm hopeful that the story of snarks, which is something like some kind of weird academic kind of research, ended up being useful for this particularly ideologically motivated group of people to do something, and then that like kickstarted a positive feedback loop that now we're at, you know, almost 1000x slower than actually running programs. We can prove them. something like that could happen for fully homomorphic encryption or witness encryption or functional encryption or indistinguishability obfuscation, all of these like kind of really out there cryptographic primitives that are not, at least as far as anyone knows right now, practical at all. Maybe we could figure it out, you know.
I think kind of maybe combining both of those answers as well. You know, you were talking about like seeing HCPP as a TAS, and I think we're also getting to a point where like it's maybe easier to set up a TAS, like just from like the very practical to like onboarding to wallets is a lot easier and kind of immediately just like getting people into a flow of like, oh, when you know, whatever, we don't use cash, we don't use cards here, we use this. So again, we're kind of shunting ourselves away, and then if there's anything, you know, it kind of again you're removing attack surface from kind of like the thing that you're trying to get away from, right? But then also just the conceptual richness of everything that we're talking about. Everyone's had quite a lot of time now to flesh stuff out, to rattle ideas around, and to also see, you know, looking at like the talk beforehand, which was Silke talking about like how like the fact that Assange DAO like worked, which is fucking incredible. Yeah, the conceptual richness is also there. And the fact is that like we can also pull more people in and like educate people a lot easier as well, because all of these points of friction, wherever it is in the stack, all the way from like UX to just stuff being faster, is happening, right? So like the ability to set up a TAS is also lessening over time. So maybe they could become more and more spontaneous in meet space too.
Yeah, definitely. The cost has increased, and there's further, you know, potential for the cost to further decrease, and that's a great entrepreneurial potential. Right? There's numerous business models in the creation of the second realm that are very much needed and very much desired, and even pretty low risk. So it's a good opportunity to become active and be part in building this. And I think there's of course a lot of interesting thoughts in the book The Second Realm about this, including of secure perimeters and surveillance that you actually know when you're being attacked, and delays for the attacker, etc. But I think a critical aspect is redundancy, to not just have one TAS but a network of TASes, and with secure travel in between them and evacuation protocols, etc. So that whenever there is the potential for a big conflict, especially with a well-funded adversary who can outgun you, de-escalation is a sane and practical aspect of packing up your capital, take everything with you, and leave, and give nothing to the attackers, simply evacuate and be productive somewhere else.
Yeah, very much so. And I mean, like, we've actually seen an IRL use case of this with the community structures in Chiapas, right? In the last couple of years, they have decentralized. They've removed, they were already decentralized, but there was kind of these like kind of councils of councils and these like larger substructures, and they've chopped off the top of that pyramid and further decentralized themselves in a very real, like in this, and they're obviously dealing with like paramilitaries, they're dealing with governments, they're dealing with logging companies, they're dealing with all of this, but they are also like running parallel societies and have been for a very long time. And we saw this a couple of years ago. So like that's almost the thesis is that we have some answer to that hypothesis as well, right? And that we've seen. So yeah, it's heartening, I suppose. Or well, not heartening, you know what I mean. Let's do it.
Yeah. I'm just very optimistic every time I come here and see all the like-minded people that are working towards the same future. And we're building the tools, we're building the community, so we'll make it.
Do you have any more questions from the audience? Up there.
You guys were talking about making privacy by default on chain. How do you keep people from discriminating against people who use privacy? Can you ask that question with the mic? Yeah, how do you keep people from discriminating against people who use privacy on chain?
Yeah, that's a big issue. Always has been with cypherpunk tech, because people see that something is ciphertext. You know with which protocol it was encrypted, at least with many encryptions, right? So this has always been somewhat of an issue. I guess it stops being an issue when simply the overwhelming majority of traffic is encrypted. which is probably the case nowadays with HTTPS. So there is this turning point where it's no longer weird to have encrypted traffic, at least of this type. And then the other alternative is steganography, so hiding in plain sight. For example, the latest Bitcoin peer-to-peer protocol produces perfectly random bytes from the first handshake on. So this means that now other applications who use the same fingerprint all just look like perfect random noise, and nobody exactly knows what type of protocol is happening in there. So there are such tools, and it definitely is an issue.
I guess adding on that, if privacy is combined with some other desirable property that people who might otherwise not be interested in privacy care about, like scalability, then if the two are not separable, then you kind of get kind of a larger anonymity set for free, right? People who care about scalable transactions have to be private just by nature of the scalability question itself.
Fully agree. This is how we win.
Yeah, and it is definitely a useful side effect, right? Of when we have systems that do not require everyone to share data about his transaction to a public network. Inherently, it's much easier to verify if you don't have to listen to all the garbage, and much harder to track. But of course, there are not ZK schemes, but snark schemes that are not zero knowledge. So where you have succinct proofs of computation and such, but certain aspects of the input leaks in the proof. So these are sometimes even more efficient, I think.
Yeah. I mean, it's worth pointing out that snarks are not by themselves like a privacy-enhancing technology. I mean, I don't know. I struggle with this personally sometimes. There's like ways in which it can make it easier for people to force you to reveal more fine-grained information, which might make it more palatable for people to accept invasions of privacy. But anyway, I mean, the ZK property itself is kind of an academic thing, right? Snarks are information hiding in the sense that they compress, right, like lots of stuff into a very small amount of data. So if something isn't revealed via the public inputs, whether or not something is ZK is not, that important. But yeah, I agree. Like snarks are not by themselves privacy enhancing.
Yeah, so again, there's some technical solutions to this problem, but ultimately it's a social one, right? If it's simply everyday practice by everyone to use privacy-preserving technologies, then this is solved. But that's not an answer to the question, because it's not a strategy of how do we get there. I guess one part of how do we get there is by building tools that are faster and easy to use and cheap, that are privacy preserving and that are first and foremost useful, that people actually end up using them, and that it solves problems for them. Further questions, please.
Time's up.
Ooh. Thank you very much.
Thank you very much.
My colleagues.